Yeah? Okay, so what I'm doing is I'm finding absolute and max and min values within this domain. All right, so first what we have to do is we have to find the derivative. So f prime of x, so this is a product rule. We're going to find the derivative of the first function, which is 1 times e to the exponent x divided by 2, plus the derivative of that is e to the power of x divided by 2, and then the derivative of x divided by 2 is 1 divided by 2 times x, the first function. And we're going to bring e, x to the 2, to the outside. In the brackets, we're going to have 1 plus x over 2. All right. So now we're going to have to set that. We're going to have to set the derivative to 0. So set f prime of x equal to 0. We're going to have e to the exponent x divided by 2 times 1 plus x divided by 2 equals 0. All right, so e x to the 2, x can be any number here. For this one, we're going to do 1 plus x divided by 2 is equal to 0. We're going to bring the 1 to the other side. We're going to bring the 1 to the other side, which is x divided by 2 is equal to negative 1. So x is equal to negative 2. We see that this critical point is in the domain of negative 3 to 1. So we can use that as a critical point. Next up is we're going to have to plug in 3 values. We're going to plug in negative 3, 1, and negative 2 into the original equation. And we're going to see what our points are. So we're going to have f of negative 3, which is equal to negative 3 e to the exponent of negative 3 divided by 2. We're going to bring the e down. And negative 3 over e to 3 over 2. That's approximately 4.5, so we have negative 3 divided by approximately 4.5-ish, which is approximately negative 0.66. All right, so our point here is negative 3 and approximately negative 0.66. So next one we're going to do is we're going to plug in 1. So we have f of 1, which is equal to 1 times e to the 1/2. All right, so we're going to have, this is approximately 1.7. So we're going to have, the point here is 1 and 1.7. All right, and then we're going to plug in our critical value. X is equal to negative 2. So we're going to have f of negative 2 is equal to negative 2 times e to negative 2 over 2, which is negative 2 over e, which is approximately negative 0.74-ish. So this point is negative 2 and negative 0.74. So now we can assume, you could plug it in and do a second derivative test, but we see that this is the only positive y value. So we know that our absolute max, is at 1 and 1.7. Absolute min is going to be at point negative 2 and negative 0.74, because we see that negative 0.74 is a lower y value than negative 0.66, so we know that's going to be our absolute min. Put that down, negative 2 and negative 0.74 is our y value. There you have it. There's our absolute max and there's our absolute min. Right, for my second question, I'm going to get the absolute max and min values for the function f of x is equal to ln of x squared plus x plus 1 in the domain negative 1 and 1. Alright, so first thing what we have to do is we have to get the derivative of the function. So we're going to f prime of x is equal to, since this is a chain rule, first thing, the derivative of ln of something is 1 over that. So 1 over x squared plus 1 plus x plus 1. And then the derivative of the inside would be 2x plus 1, right? So then we're going to put 2x plus 1 over x squared plus x plus 1, right? So next thing what we have to do is we have to set our derivative to 0 in order to find critical points. So what we're going to do is we'll set f prime of x equal to 0. So we're going to have 2x plus 1 over x squared plus x plus 1 is equal to 0. So we're going to multiply both sides by the denominator. So x squared plus x plus 1 on this side is going to cancel out, and on this side is times 0, so it's going to be 0. So we're going to have 2x plus 1 is equal to 0. We're going to have 2x is equal to negative 1, and we're going to have x is equal to negative 1/2. Is that in our domain? Yes, it is in our domain, because negative 1/2 is greater than negative 1 and less than 1. All right, so next thing, what we have to do is we have to plug in our critical x value and our domain into the original function. So we're going to have, first we're going to have f of negative 1. We're going to have equals to ln of negative 1 square brackets here, negative 1 squared plus negative 1 plus 1, which is going to be ln of 1 minus 1 plus 1, so it's going to be ln of 1. So this point is negative 1 and ln 1. Alright, next we're going to have our domain value. Our critical x value. F of negative 1/2. So it's going to be equal to ln of square bracket negative 1/2 squared plus negative 1/2 plus 1. It's going to be ln of 1 over 4 minus 1/2 plus 1. Just common denominator quick. Ln of 1 over 4 minus 2 over 4 plus 4 over 4, which is going to be ln of 3 over 4. I believe, yep. Ln of 3 over 4. So this point is going to be negative 1/2 and ln 3 over 4. And then we're going to plug in our last value, 1. F of 1 is equal to ln square bracket 1 squared plus 1 plus 1. So that's going to be equal to ln of 3. Alright, so our point here is 1 and ln 3. So for our absolute max, we're going to have this one right here, the point 1 and ln 3, because we know ln 3 is the highest y value. So we're going to have 1 and ln 3 as our absolute max. And then for our absolute min, we're going to have negative 1/2 right here, negative 1/2 and ln 3 over 4, because that's the smallest y value. Ln 3 over 4 is smaller than ln 1 and ln 3, obviously. So that's going to be our absolute min. Negative 1/2 and ln of 3 over 4. So there we have it, our absolute max and our absolute min. Thank you.